Hello! So here we have the equation log base 3 of x plus log base 3 of x plus 1 is equal to log base 3 of 2 plus log base 3 of x plus 3. Okay, well, what we can do is, since we have sums of logs with the same base, we can rewrite that as just a single log of a product, right? Because if we have log of a product, we can rewrite that as the sum of the individual logs. So since here we have the sum of the individual logs with the same base, we can rewrite the left-hand side as log base 3 of the product then of, that would be x times x plus 1. So x times x plus 1. Okay, and then that is then going to be equal to, well, log base 3 of, again, the product here would be 2 times x plus 3. Okay, and then, well, we can use the property of logarithmic identity here, where we have log base 3, same base. If these things are equal, that means the arguments here must be equal. That means that x times x plus 1, x times x plus 1, the x distributes. That's going to be an x squared plus x. That's x times x plus 1 must be equal to 2 times x plus 3. Well, 2 times x plus 3, the 2 distributes, and that gives us a 2x plus 2 times 3, so plus 6. Okay, so now here we have x squared plus x is equal to 2x plus 6. We no longer have any logs. We can then go ahead here and just combine our x terms and our constants, basically set this equation equal to 0, and that is then going to give us, well, we have an x squared, and then we have an x minus 2x gives us a minus x, and then subtract the 6. So x squared minus x minus 6 is then equal to 0. We now have a trinomial here that I think is going to factor nicely. Let's try and factor this into two binomials that'll still be equal to 0. Well, we have an x squared. That has to be an x times an x. Now a 6. To get to a negative 1 in the middle, I think we need a 3 and a 2, right? Because 3 times 2 is 6. We have to then add to a negative 1x. So that's the minus sign has to be on the 3, the plus on the 2. That's an x squared plus 2x minus 3x is a minus x. And then minus 3 times 2 is a minus 6. Okay, cool. So now we have x minus 3 times x plus 2 equal to 0. That would imply that either x minus 3 is equal to 0, which would imply that x is equal to 3, or that x plus 2 is equal to 0, which would imply that x would be equal to negative 2. So for this equation, we have two values of x that both satisfy this equation, but wait a minute, this has to satisfy the original equation, which is a log equation, and the argument of a log cannot be negative. So here, we can go ahead and discard the negative result here, because negative numbers do not have real number logarithms. So therefore, we can discard the negative result, and the only answer to this is going to be x is equal to 3, which we can see if we graph this, right? We put the equation here into Desmos. So here we have log base 3 of x plus log base 3 of x plus 1 is equal to log base 3 of 2 plus log base 3 of x plus 3. We put that in the Desmos, and we see we get a vertical line. That vertical line is going through 3, right? That is the vertical line of the equation x is equal to 3, which verifies our result here that x is equal to 3. All right, take care.